as scientists, we try to solve riddles, problems.
All right.
Sometimes those problems are just really kind of run-of-the-mill daily issues. I'm involved with a redevelopment project down in San Diego. It's a small project in San Diego called the San Diego Sports Arena. It's 48 acres. They're going to redevelop it with a new arena, some commercial retail, entertainment, and some housing.
They're gonna want the Chargers back?
No, and this is the Gulls play at the arena.
Okay.
And if we ever had a basketball team again, they would play at the arena.
Okay.
We do historical research, then we go out and we investigate the site, and I'm managing the environmental aspects of it. So my job is to find out what environmental issues they're going to run into when they go to redevelop, and how we're going to deal with those during the grading and development of the new facility. And we had some information that there was some burn ash deposits down there. And that's where you'll find a lot of glassware and stuff, and a lot of this was lead crystal. So as it burns, melts, breaks, whatever, it mobilizes lead. And you get high lead concentrations that need to be mitigated in the soil. And the site was first developed as frontier housing in the early 1940s. And that was temporary housing for military and construction, barracks-style apartment structures. And that continued up to the mid-60s when they tore all that down and built the arena. And we knew that there was a burn ash area at the southwest corner of the site. And looking at the air photos, it looked like it was in one of the yard areas from frontier housing. And there's a number of yard areas throughout the area that I can see in the 1940 and 50 area photographs. So I thought we could find these little burn deposits all over the place out there.
Right.
We thought they probably heated with heating fuel. And there could be underground heating fuel tanks all over the place that would have leaked and need to be mitigated and stuff. So we did hit the burn ash in one of the borings that we drilled, and the borings are this big around. So, and we knew it was in that area, so we were going to trench down there to try to delineate the extent of this burn ash deposit, this burn dump deposit, so we'd be able to come up with some costs to get rid of it. Well, in the trenching, one of the first trenches I dug down there, I came up with this bottle. I like these medicine bottles. They're kind of cool.
Yeah, they had cork.
And this one is for Mrs. Winslow's soothing syrup.
There you go.
From the Anglo-American Drug Company, successors to Curtis and Perkins proprietors.
By full cocaine.
So we did a little bit of internet research. Mrs. Winslow's soothing syrup was touted as likely to soothe any human or animal, especially infants and toddlers during teething.
Right. Cocaine.
Mrs. Winslow's soothing syrup was composed of morphine and alcohol.
Alcohol. Yeah.
And this was actually featured or discussed in a 1911 article by the American Medical Association titled Nostrums and Quackery.
Yeah.
And Mrs. Winslow's soothing syrup was incriminated in the chapter of that article titled Baby Killers. Nevertheless, Mrs. Winslow's didn't come off the shelves until about 1930.
Right.
Why is that important?
Takes too much time to make it
It was
change.
more important to get the baby to be quiet.
That's important because frontier housing was built in the early 1940s, and my concern was that we would find these deposits associated with frontier housing. This predates frontier housing significantly,
Right.
and I found no other trash deposits anywhere.
Oh.
So it's likely that frontier housing, their trash probably went over to the Mission Bay landfill. As far as the tanks go, we did geophysics and saw these lines everywhere. And when we trenched and looked at those lines, they turned out to be natural gas lines.
Huh.
So SDG&E was providing natural gas service as early as the 1940s, and apparently frontier housing was on natural gas.
Yeah.
So that took out the possibility of finding underground tanks all over the place.
Right.
It's significant to me because it really significantly reduced the complexity of the environmental picture that I have to interpret and develop and provide to the client by the end of this coming week a construction cost estimate for what it's going to take to mitigate stuff.
As long as you didn't find any bones.
Well, I'm not telling you there's no bones out there, but whatever. Science can actually provide us with a lot of information and a lot of very useful stuff. But even at that, it's providing, it's not telling me, here's what it is. It's telling me, here's a better model. Your model was frontier housing would have all these trash dumps and underground tanks all over the place. Now I've got a better model. There's an old trash dump, we can get rid of that, otherwise there aren't any, and there won't be underground tanks everywhere. I found one underground tank, it's by the old school. It makes sense that it's there. It's still interpretive. I may go out there and find trash pits all over the place when they're doing the grading, who knows? But at least I have a better model now, based on some information. And that's what we're doing here today, is we're building a better model of the coming about of all things by looking at all this science, but looking at it through different philosophical eyes. So where are we in the grand scheme of things here? You guys have heard the Goldilocks Zone in terms of our solar system. If we were a little closer to the sun, it would be hot like Mercury.
Right.
If we were a little further away from the sun, it would be like Mars.
Yeah,
But we're right here in the Goldilocks Zone.
just right.
It's just right. Well, there's a lot more to it than just that. The next series of slides is coming from The Privileged Planet, this book here. And I want to read one passage in here to you guys before we get too far into it. From an eclipse to an insight. Perfect solar eclipses are perhaps the most aesthetically striking. By the way, is anybody going to Texas or thereabouts next April for the total solar eclipse?
I wish.
The turtles may be there.
Yeah.
Okay.
They live there.
Are you going?
I am absolutely going. God
really?
willing.
Huh.
And I'll explain more in a minute. Perfect solar eclipses are perhaps the most aesthetically striking example of the correlation between habitability and observability. Yet the correlation in this case is more encompassing, since it applies also to measurability and discoverability, both of which are subtly different from observability. Earth is ideal for observing perfect solar eclipses. Beyond this, perfect solar eclipses are optimal for measuring a range of important phenomena, such as the solar flash spectrum, prominences, starlight deflection, and Earth's rotation. But even more than this, perfect solar eclipses provide great opportunity for discoveries about the sun.
Right.
Finally, besides inspiring awe and allowing us to discover the nature of the sun's atmosphere and the element helium, both unanticipated, perfect solar eclipses became the occasion for discovering the correlation between habitability and measurability itself. Hardly an insignificant point.
Right.
Now, I just said a lot of words from a book written by, among other guys, a PhD. And don't worry if you don't have your head completely wrapped around the significance of what I just said. You will soon.
I think I understood.
T.S. Eliot said, "We shall not cease from exploring, and the end of our exploring will be to arrive where we started and know the place for the first time."
Yeah.
We are explorers. We don't like to just sit in a room and look at a wall. We want to go out and experience things, discover things, find out things. How many people through the ages have done wondrously amazing stuff by simply getting on a ship or on a train or on a plane more recently and going out there and looking at new stuff? For a while there, for a brief moment, I thought I had discovered Hauser Man. Now, this is a photograph that Carl Sagan used to try to tell us how absolutely insignificant we are, that we really don't matter in the grand scheme of the universe. It was taken February 14th, 1990 by Voyager 1 at a distance of 4 billion miles, basically right out at the edge of our solar system, which in 1990 means it would have been outside Pluto. Later on, it would have been further outside the edge of the solar system after Mike Smith managed to get Pluto deplanetified.
Yeah.
I think it's still a planet.
Mm-hmm.
Anyway, the pale blue dot, do you guys see it?
The pale blue dot.
The pale blue dot is right there.
Yep, I seen it.
That is Earth from a distance of 4 billion miles.
Yeah, right.
Sort of illuminated in a light ray sort of thing. And again, Carl Sagan, who was an absolute atheist, we're insignificant. We don't matter. We don't mean anything. So we're going to ask the question, is the Earth privileged?
Yeah.
We're going to see some striking examples of just how privileged
Nothing else
we
out
really
there looks
are.
like that.
Well, I mean, you just look at that,
Yeah.
and it looks anything but, you look at photographs of any other planet in the solar system,
It's nothing.
and it's like, that's the last place I want to go.
Colorless, everything.
Now, Jay Richards is the philosopher author of Privileged Planet, and he says the recipe for life is much more complex than just add water.
Yeah.
There's a number of things that need to occur in order for life to exist. We have to be within the galactic habitable zone. We're going to look at each of these individually. Orbiting the right kind of star. And you guys all knew this, but we orbit a spectral type G2 dwarf main sequence star, right? I mean, everybody knows that.
Oh, sure.
We're protected by the giant planets. This is interesting. We're within the circumstellar habitable zone. That's the Goldilocks zone you've already heard about. We have a nearly circular orbit. Oxygen-rich atmosphere, the correct mass, orbited by a large moon, magnetic field, plate tectonics, ratio of liquid water to continents. We're a terrestrial planet, and we have a moderate rate of rotation. So let's pick these apart a little bit. We're within the galactic habitable zone. So within the Milky Way galaxy, we are about halfway, roughly, between the center of the galaxy and the edge of the galaxy. This is important because, first of all, here in the center of the galaxy, first of all, many galaxies, including ours, have what the scientists love to refer to as a supermassive black hole, and that they compete with each other with who's got the biggest black hole. But there tends to be a black hole at the center of the galaxy. And it makes sense because the center of our galaxy is the point where there is the most mass, there is the most stuff to gravitationally come together and condense to the point that it becomes a black hole. A black hole is just an object that is so dense that not even light can escape it. And they always look like, you see a black hole, you see a ring of light. And what you're seeing is the light that's hanging right at the edge of escaping and being pulled back in. So it looks illuminated, but anyway. But that's also where there's a lot of star formation going on. Just a lot of processes that, folks, you would not like it there. It's just a dangerous, dangerous place with stuff flying around and all this stuff happening and getting sucked into black holes. And we're not there because that wouldn't be a good spot for us. Out here at the outer edge of the galaxy, that's not a good spot either. As you get away from the center, the density of the galactic material itself gets lower and lower and lower and lower and lower. And by the time you get out to the edges, there's not enough of the kinds of elements needed to have an Earth-type planet. If we were out at the edge of the galaxy, our planet would probably just kind of fall apart into dust and be done. Now, you're having to assume that it formed in the ways that people say. I think God made the heavens and the earth, and there's the earth. Nevertheless, we are in a spot in the galaxy that is conducive to our survival. And more than that, which we'll get to shortly. We do orbit as I said before, and you'll always remember this now, a spectral type G2 dwarf main sequence star. It's the right size, the right color. It makes the right kind of light for us, and we'll get more into that. The right kind of radiation, I should say. And it's the right size. If it was any smaller, we might end up being a lot closer and getting into a different kind of orbit with it, and that could go bad when one side of the Earth always faces the sun, the other side faces away. There's basically this line that people can live on. We are actually protected by the big gas giant planets outside us, Jupiter, Saturn, Uranus, and Neptune. They are mostly gas, but they are huge, and they have a huge amount of mass, which means they have a huge amount of gravity compared to us. And so when all those pesky comets and asteroids come flying in from the Kuiper Belt and out there, they can hit the Earth, and there have been asteroid impacts on Earth that we know just from geology were very impactful. They say that 65 million years ago, an asteroid hit the Earth that caused the extinction of the dinosaurs. Age of the Earth aside, that is the kind of event that could indeed cause the extinction of the dinosaurs or us or whatever. But the gas giants tend to suck up a lot of that stuff out there as it's coming in. They get captured by their much more massive gravity, and they get pulled into them. We're in the circumstellar habitable zone. This is the Goldilocks zone. If we were a little bit closer, our planet would be more like Venus. If we were a little bit further away, we'd be a lot more like Mars. But we're in the right spot. We also have a circular orbit. You know, it's not elliptical, so it keeps our situation fairly stable, but not completely stable, and we don't want it to be completely stable. That's coming. We have an oxygen-rich atmosphere, and that tends to do a couple of things. It protects us from radiation. It's also correct for life, because obviously carbon-based life forms need oxygen to survive. Yeah?
Oxygen, yes, it gives us life, but it's a good thing it's at that right concentration, because anything higher than that and it'll become deadly.
Well, yeah, the oxygen concentration is supposed to be about 20%. Some of what I do environmentally involves getting into situations where I can be in a hazardous atmosphere. And that can be, among other things, that can be a high or a low oxygen atmosphere. The instrumentation that we will wear when we have to go into an atmosphere that could be harmful will alarm at about 19.5% oxygen, and I think it will alarm at about 23% oxygen. So anything below or above that, it's oxygen deficient, and we don't. I had COVID a few years ago, and I got to spend 10 days in the hospital with it. And for me, it was on oxygen with some antiviral drugs, some steroids, a lot of vitamins, and I got better and went home. But, you know, when my blood ox was getting down around 88%, I was still at home and I could barely move. Oxygen deficient environments or atmospheres are not good for us.
No.
We tend to lose it. And if it's too much oxygen, it can be flammable or explosive. I mean, you can breathe pure oxygen, but oxygen just has a whole host of hazards, mostly having to do with its flammability.
Yeah.
But our atmosphere, for the most part, is just right for us.
Yeah.
We are orbited by a large moon. And what this does is, well, we're going to get a little bit more into this, but of course the moon has a lot to do with tides, mixing ocean nutrients, things like that, regulating seasons and winds. Did I miss a slide? No, I didn't. I hope I didn't take a slide out last night inadvertently.
All right.
Oh wait, no, this is not, that's not the moon.
It certainly isn't.
It's
That's
the Earth. Our Earth is the correct mass. Boy, that was confusing.
Okay.
I'm sorry, you could have caught me earlier, come
You're
on.
doing great.
If our mass was much lower, we would lose atmosphere. If our mass was much higher, we would retain bad atmosphere. We also would be a bigger target for those things coming in from the outer solar system. So in a way, we're just exactly the right size to be hiding in plain sight.
Right.
Things don't tend to hit us like they hit other planets. We have a magnetic field, and that actually protects us from the sun's radiation. It does something else too. Have any of you ever seen this?
Oh, the northern lights.
This is actually a photograph that my daughter Juliana took. A few years ago, she and some friends went up to Fairbanks to see the aurora.
Oh, yeah.
And I sent one of my good cameras with her, with a tripod and a little remote shutter, did a few presets, and sweetheart, see if you just get a couple pictures, you know, it's just something, it'd be nice to see. She took like 140 shots that night, and they're all like this.
They all look the same.
And now I want to go too.
Oh, yeah.
Now here's where we do the moon thing that I started earlier. We are orbited by a large moon, and this has a few effects. It causes seasonal changes in wind, and that kind of distributes rain a little bit more broadly. It affects tides, which mix nutrients in the oceans. And it helps generate the currents, which also generate heat, moderate climate. So the moon does a lot to help our climate be conducive to us,
Yeah.
as opposed to, imagine you either have the Sahara Desert or the North Pole. And there would be places, without the moon, it could be like that, where it's basically one or the other and nothing in between. We have plate tectonics, and as a geologist, I like this part because plate tectonics are fun because they make earthquakes and tsunamis, and those are fun, right?
Well, you're not in them.
Right.
Well, we had an earthquake in 2010, we called the Easter Sunday earthquake. Did any of you feel that?
Yeah, I think I did. That's the one they had out in the
Northern Baja.
yeah. Oh, northern Baja.
Northern Baja, yeah. It was a magnitude 7.3.
Yeah.
It lasted 60 seconds,
Yeah.
about a minute. And when it was over, I mean, it really shook at our house. I was disappointed. Oh, it's over. Geologist. Basically, the plate tectonics regulates Earth's interior. With the ages we're talking about, it may not be as important as you'd think, but it is a note to put in here. Recycles crust, albeit very slowly, but also mixes nutrients, shapes continents. We're on a very dynamic planet, and those dynamics, it turns out, tend to be really good for life. And they also just make this a really interesting place to live. And I think that is important in terms of the way that God made us. The ratio of liquid water and continents. This goes back to Jay Richards' comment that the recipe for life is much more than just to add water. With the right mix of water, continents, dynamics, you get a recipe for really abundant life. If you've been to a forest, if you've been to a beautiful desert, if you any place, the Great Plains, wherever, you get to see this in action, where the earth has the right amount of water, the right amount of land, just the right mix to produce a tremendous diversity of life.
Right. Deserts.
People talk about life. We have found life on Mars. What did we find? We found single-cell things living or having lived in this ice that's underneath the surface of Mars.
Yeah,
Well, that's living.
Living it up.
Living it up. We're on a terrestrial planet. Basically, our planet is made of the right stuff to support us, to support life, to support development of soil, growth of plants, all the dynamics that make this work. Back to Psalm 19:1. The heavens are telling of the glory of God, and their expanse is declaring the work of his hands. And when we look at all these things, we can see God's design in putting us in a place that's particularly conducive to our survival.
Yeah.
In The Privileged Planet, Guillermo Gonzalez and Jay Richards sort of semi-arbitrarily assign chances to all of these different factors actually coming together to exist here on Earth. And they come up with an overall chance of like 1 in a trillion? Wait, 100,000 million, billion, 1 in
what
1
is that?
quadrillion?
Yeah.
Chance. So now if they're correct, if the chances of all of these different conditions existing on a planet that are conducive to life really is that astronomically small,
Yeah.
all those other planets they're talking about through the universe,
Can't have
they
it.
all of a sudden they're not. It's not enough
It's not.
for there to be another one of these.
No.
I'm not going to tell you that there isn't another Earth-like planet somewhere, and I'm not going to tell you that it doesn't support life. That's up to God. If God made another one out there somewhere, great. Can't wait to meet my cousins. But here's something that Jay Richards says. If Earth exists for a purpose, is there any way that we could tell? And he means a purpose other than just supporting our life.
That's what it was made for, right? For us.
Well, the answer to that question is yes. And the example that they use in The Privileged Planet is these things. Eclipses.
Oh, wow.
Eclipses allow us to observe a part of the sun critical to understanding how its light is formed. This goes to the observability and our discovery. In eclipses, we can observe the corona.
Yeah.
We observe the chromosphere, and that's the low atmosphere right around the sun. We can also learn something about Einstein's theory of relativity, and that has to do with seeing light bend around the sun during an eclipse, which we wouldn't see otherwise. And by the way, in 2017, I did go up to Payette, Idaho, to photograph that solar eclipse, that total eclipse. The upper right picture is not mine, but that panorama is mine. One of my friends that was up there with us, I had this set up on a tripod, and he did a series of panoramas during totality, and we stitched them together. So that's actually 360 degrees, and you'll notice it looks like sunset in every direction.
Yeah.
You see that during a total solar eclipse and no other time.
Huh.
You're literally looking at the bottom of the shadow of the moon.
Oh, wow.
So we can observe the corona. These are both pictures that I took during that eclipse. And you can, I mean, folks, it's amazing. If you have a chance to go to Texas or somewhere in April next year and see that eclipse, I highly recommend you do it. It takes about 20 seconds to go from absolute daylight, kind of dim, but daylight, shadows and everything, to basically night. A friend of mine took a 19-second movie, and that's what you see, is everything changing from daylight to, okay, now it's like nighttime. You see light off in the distance. And at that point, the solar glasses come off, the solar filters come off the cameras, you look up and you see the dark spot, and you see the corona. You're just looking at it with the naked eye. You don't need any filters or anything. These were taken with my cameras, and so these are both the same eclipse, and you notice here the corona seems to be going this way, here it's going this way. That's because this camera was on a fixed tripod, that camera was on a clock drive tripod, polar mount. So it actually follows things on a single axis, and the camera's going to be kind of tilted at an odd angle most of the time. But those are two pictures of the same eclipse, and you get to see the corona. That's the sun's upper atmosphere.
Yeah.
You also get to see the chromosphere. A couple more pictures or processes from my photographing, and you can see this white and red stuff around the edges.
Yeah.
And there's kind of an up close of the upper part. There were two solar flares that were really prominent
Yeah.
during that eclipse. So here's the question. Is it a coincidence that the sun
Fit just perfect.
is almost exactly 400 times larger than the moon,
Yeah.
and the sun is almost exactly 400 times farther away?
Yeah, that's not a coincidence.
That is the reason that we have the best eclipses in the whole solar system.
Right.
Because when the two come together,
The distance makes them.
the moon perfectly covers the sun.
Right.
This October, and you'll see it in Texas, there's going to be an annular eclipse. That's where the moon's a little further away, so when it covers the sun, there's still a ring of light around. Okay? You don't see any of this stuff if there's even just a little sliver of light, because it wipes out the corona, it wipes out the chromosphere, it wipes all that stuff out. If there's any of the visual light that the sun produces, you won't see all that stuff.
Right.
But during a total solar eclipse, they're perfect. It fits perfectly.
It's the same with the moon and the earth, the shadow of the earth, right?
Well, the point
The moon eclipse.
the point is that during that eclipse, the penumbra? I forget. Anyway, basically comes down to a point that I think the totality during the 2017 eclipse was about 70 miles across. And in the 2024 eclipse, it's going to be about 140 miles. Totality would be 4 minutes instead of 2 minutes next April. I can't wait. I didn't have enough time to just look at it. I was messing with cameras the whole time. So the only place that has observers also has the best eclipses. Now, they also say, what if the characteristics that make a place habitable also make for the best observations? We've been talking about these. Our atmosphere, for example, is transparent. The atmosphere on Venus, the atmosphere on Jupiter, the atmosphere on Saturn, Uranus, Neptune, they're not transparent.
Articulate.
You can't see through the atmosphere on those planets, but you can here. The same narrow circumstances that allow us to exist also provide us with the best overall setting for making scientific discoveries. Now, this is where I want you to start thinking about, what has God done for us here? Has He just put us in a place where we can survive? Or has He also put us in a place where, without having to go too far, we can explore the universe? We have instrumentation that is seeing to the very edges of the universe. Back to the sun for just a moment. We have a thin atmosphere. 7 of the planets have a gas atmosphere. Earth is the only one that sustains life, and it's transparent. The radiation types, gamma, X-ray, ultraviolet, visible, infrared, microwave, radio, the electromagnetic spectrum, which you see there. Most are useless or lethal. One is necessary for life and visible, and happens to be the type our sun makes in abundance. There are stars out there. You could be as far away as from our sun, and you might not see that star, because it is not producing visible light radiation. It's producing, say, gamma, in which case you'd be dead. It's producing some other type of radiation. Our sun produces mostly visible light radiation. And it illuminates everything, and it allows us to see stuff and eclipses. This is a remarkable coincidence that the type of atmosphere needed for complex life does not preclude that life from observing the distant universe. Again, so our habitability and our observability seem to go hand in hand.
Right.
And there's going to be a statement coming up shortly from Jay Richards that I really like. But this next slide, this is important. Think about this. Earth is located between the Sagittarius and Perseus arms of the Milky Way galaxy. In the center, it's kind of bad. High density of stars, supernova, black holes, radiation. The edge, it's bad because it's a low concentration of the elements necessary for Earth-sized planets. So we know we're kind of in the middle. But we're taking that a step further now. Within the spiral arm, it's bad. That's where there's a lot of star formation and supernova, and it'll be foggy. I mean, you know, you're in a gaseous arm of the galaxy. We are between two spiral arms of the Milky Way galaxy, which not only keeps us away from a lot of those dangers, it's also put us in a location where we can look out to the edges of the universe.
Yeah.
Now think about that. Earth is located between these arms of the galaxy. It's in the optimum position for seeing both the nearby structures of the Milky Way galaxy as well as seeing the cosmos as a whole. And I have proof. On the right is the Andromeda Galaxy, taken by a professional astrophotographer, I'm not sure who. Probably a number of images stacked together. And you can see the dust lanes in the galaxy, these dark kind of brownish things here. You can see M32, the little companion galaxy to the side of M31. Well, this is a photograph of the Andromeda Galaxy taken by this really amateur photographer named Chuck Hauser. It's not as good as this. I don't have the equipment to do that. But you can see the dust lanes in here. You can see
you did pretty
M32.
good. Yeah.
The fact that I can take that picture is a testament to our location within the galaxy and its observability of the universe. I can take pictures of the universe from right here.
Did you use an iPhone?
Yes.
Okay, wait outside.
Slow down, Jim.
I used a Nikon D5100 for that.
Oh, yeah.
Although now I've upgraded to a Nikon D7500. And if anybody wants to talk about that later, we can. The universe is finely tuned for our existence and to be observed and understood. Here's a few quotes from some other folks. Well, one from Guillermo Gonzalez, but two from Albert Einstein. The most incomprehensible thing about the universe is that it is comprehensible. And I have deep faith that the principles of the universe will be both beautiful and simple. And that's what we're kind of finding. When you take out all this chance, random stuff flying around, and you just boil it down to God made it, and He kind of put it there for us to look at and discover and find out things, that's pretty simple. And this is coming from the PhD astrobiologist, Guillermo Gonzalez. Whatever the source of the universe, it intended that it contained observers who can discover it. And this is the quote from Jay Richards that I really like. The conditions necessary for complex life are optimal for making a wide range of discoveries. It turns out that those are also all the most important conditions for a habitable planet. Excuse me. That is, a planet that's conducive to beings like us. That's the sort of thing that should suggest conspiracy rather than mere coincidence. In other words, that should suggest design.
Yeah.
That there is an intelligent designer behind this universe.
Yeah.
And not only did that designer, God, intend for us to be able to survive the universe, he intended for us to be able to observe the universe. I love that. There are so many possibilities of how this could have been, how we could have been, if this was just random chance. But here we are in a spot that's absolutely perfect for us to not only survive, but also to observe the universe. Sometimes you get that little scratch in your throat, and it's just like, it won't go away. Okay, I think we're just about done with this part. Nicholas Copernicus, the mechanics of the universe, wrought for us by a supremely good and orderly creator, the system, the best and most orderly of all, framed for our sake. I love to let some of these scientists speak whenever they can, because what they have to say really goes to this whole idea of the consistency between God's word and what we observe in science. And finally, in this section, the universe is not just for us to exist, but for us to extend ourselves beyond our small home and view the universe at large. And that, in a nutshell, is what I try to get across with this particular section that we just finished. And I don't need to say it again. Any questions? There are questions? Thoughts? Comments? No?
It's interesting.
The deal with the tilt of the earth, as you were going around that, at least I didn't hear it. And I think that's critical as well.
Absolutely, and that is part of it. And yes, in fact, in the full series of lessons I do talk about that.
Mm-hmm.
I could have talked about everything I've talked about if you all were willing to be like Paul and prolonged his message till midnight. I might have been able to get through most of this by then.
I'd be Eutychus at that point.
But yes, the tilt of the earth is actually one of the characteristics of our planet that it's amazing to me that you tilt it, 22 degrees, and now you have probably increased by 50 or 60% the actual habitable surface of the earth.
Right.
Now, this last winter, Max might not have actually thought he was living on a habitable section of the earth.
Right.
People living further north, I just can't even imagine. I've been a Southern California boy all my life, and I want the sun to go down and then the sun to come back up, and during the time the sun's up, I want it to get a little warm. But even with conditions like that, just watch all the shows about Alaska in the wintertime, those guys
Right.
flying up there. We can live with that, and there comes the time of the year when it's way different. And because of the tilt of the axis, we have seasons that we wouldn't otherwise have. So, yes. Okay. Yes.
Just a question that's not exactly what you're talking about, but I know that people that live on the East Coast and North, they're really getting punished. And here's Southern California, that absolutely is not godly, I don't think.
Probably not.
How do you define that?
I would live here rather than there.
Oh, that's your answer.
Well, okay, I mean, the farther north you go, the colder winters are. The East Coast has the benefit or the curse of the currents coming up from the south. So it brings up warm water, and it tends to exacerbate their weather patterns. Now, the fact that they've got the weather patterns is good, and that they change through the year, and there's a mixing up of things. That's part of why they do survive there. And yeah, they have a few seasons, wintertime and also hurricane or tornado time, that can be a little harsh back there. People live in northern Russia where it's a lot more harsh. People live at the southern tip of South America where it can be kind of harsh. I mean, there's a wide variety of weather that occurs all over the surface of the earth. My parents just happened to decide in around 1950 that they were done with Central Illinois. And after Dad did a stint in the Navy, stationed in San Diego, they decided, gee, that's kind of a nice place. We'll move there. And he got a job, and I was born in 1959 in Grossmont Hospital, and my brother 4 years later, and that's where we've been. My parents just decided to move there. They could have decided to move to Billings, Montana.
I've been bad.
Well, for fly fishing, that might have been okay.
Yeah.
But part of what makes our planet as habitable as it is that we have this broad variety of different conditions. And in each of these places, they change seasonally. And it's that changing and that mixing up and refreshing, if you will, that causes our planet to be, I think, as rich in life as it is. Does that make sense? Is that anything like an answer to your question?
Well, it seemed like to me that people on the East Coast get punished every winter.
Well,
They destroyed their houses.
well, they've chosen to live there.
Yeah, but everybody couldn't live in Southern California.
Thank goodness.
They're trying.
Well, I don't know. California is actually losing population these days. Texas seems to be a place to go. When we go for the eclipse, we're going to be staying at the home of Greg and Kathy Rising, who moved there a few years ago. They were members of our congregation in San Diego. There's quite a few people who have moved to Texas, Arkansas, Tennessee. Personally, I would probably move to Tucson, but my wife wouldn't have it, and as long as her parents are alive, we're not going anywhere. And they're going strong, so. And honestly, I find California much to my liking in everything but politics. I'll just leave it at that.
Yeah.
Yes, sir.
Well, man can live anywhere in the world, but God put us in the ideal spot. It's man that moved to where they wanted to go.
Well, yes, and I mean, I think that man has been able to adapt and control his environment enough to be able to live anywhere on the earth. I mean, somebody can survive near the North Pole. It would be like a cut above surviving on Mars, but they can survive near the North Pole or the South Pole. Some of those places become more regions of exploration than actually settling. If you look at population density maps of the Earth, it starts to drop off about halfway up through Canada. It drops off down toward the south end of South America. We've mostly settled ourselves in places that are reasonably. My brother just moved to Indiana a few years ago, and his first winter back there was really kind of interesting for him. Why would anybody deal with this? Well, people have been dealing with that for a long time. As far as we know, we started probably over in the Middle East somewhere. I don't know that the climate was exactly like it is now at that time, and I mean, of course, in the garden, the climate was perfect. Everything was perfect. We messed it up. But, that's probably the cradle of civilization, people say. And that's an interesting point because even the archaeologists kind of see that general region as where we started and then spread out from there. But Well, if you want to think about it this way, our spreading out was kind of part of God's design too, because when they started to build the Tower of Babel, God said, this isn't going to work, and man was scattered.
That's right.
And so, in a way, we're doing exactly what we're supposed to do by settling on the East Coast and enduring the harsh winters there and all that stuff. So, does that make sense?
I picked up some people the other day, and they were from Norway. They were here on vacation, and they live over there, and it's like they get like 2 hours of daylight in the winter time, and same like just the opposite in the summertime, and it's always cold. But when the vacation's over, they're going back home. That's where they live, and
My daughter watches this
that's where
program.
they've always lived there.
This lady, I think she's in Norway somewhere, or Finland or something, somewhere up north and dark and cold.
Yeah.
And she likes to go swimming in these icy lakes.
Yeah.
And
that's
she
the
just
thing.
settles in and sits there. It's like so nice. I don't get that. I just don't understand it.
It was cold in the
Yeah.
room.
But then again, I mean, people adapt and get used to situations.
That's true.
Go to the Midwest in the summertime sometime.
That's home.
And just try to get comfortable.
Yeah.
You take a shower and you dry off. You dry off some more. You keep drying off for a while, and finally you give up and just put your clothes on wet.
Yeah.
Let's take a short break, and then we're going to launch into the last and most fun section of this thing, because the scientists tell us that 65 million years ago, an asteroid hit the Earth somewhere around the Yucatan Peninsula, the Chicxulub asteroid, I think it's called, and that the fallout from that event caused the extinction of the dinosaurs.
There you go.
In Job chapter 40,
Behemoth.
there is a statement that God makes to Job, "Behold now Behemoth." And we're going to tie all of this together in the biblical record is consistent with the actual scientific record. And you'll see some really interesting things. So, short break and then we'll keep going.